Hi students, welcome to my channel. Here I am doing a series of lectures which is related to CBSE physics topics. So today in this video I am going to explain about the state of rest and state of motion and concept of distance and displacement and different types of motions. So please subscribe my channel. So let's begin with the chapter 8 titled as motion, and the first concept, the concept of state of rest and state of motion. How you can say that an object is in the state of motion or in the state of rest? This can be described by considering two parameters. The first parameter is the time parameter and the second parameter is the reference object. Let's begin with the first parameter, that is time parameter. For this, I'll give you one example. Imagine that you have a bottle like this and you're just placing this on your table. Now it is 10 o'clock. After half an hour, that means at 10:30, you're again coming and observing this bottle. You can see that the position of the bottle is not changed. That means the position of the object, that is your bottle, is same as like you kept before. So here, if the object is not changing its position according to the time, we can say that this object is in the state of rest. Clear? I'll give you one more example. I'm just taking your attention to a playground. There were many students who were playing some football. So among those students, I'm taking out one student named as person A. When you observe the person A, he's continuously changing his position one point to the other in each seconds or in each minutes. So if the object, that is person A, is changing its position according to the time, we can say that that person or that object is in the state of motion. One more example, imagine that the vehicle on the road. When the vehicle is traveling from point A to point B, then you can say that the vehicle is moving or that object is in a state of motion. So I think the first parameter is clear. We are moving to the second parameter, that is reference object or reference surroundings. What is actually meant by? Imagine that you are simply sitting in your room. Suddenly, one of your friends came from outside and visiting you. You are just sitting on the chair without moving. So according to the friend who came from outside, you are just sitting on the chair. So you are in the state of rest, isn't it? I am taking the same friend to the other planet. Now you are in the Earth planet. One of your friend is standing on the other planet and observing you from there. By the time you know that Earth is revolving, that means you are also in a rotation motion. So according to him who is standing at the other planet, you are in the state of motion. This object, your friend, is known as reference object. Then what is reference surroundings? I'll give you one more example for this. Imagine that you are traveling in a train from point A to point B. Your friend is standing outside, that means in the station. So according to the person who is standing at the station, now this train is going to start from point A to point B. So the train is moving now. The friend is standing at the station and waving the hands. According to him who is standing at the station, you are sitting on the train, you are in the state of motion. The same friend coming inside the train and sitting beside you. Now you both are in the same cabin. So according to him who is sitting near to you, you are in the state of rest. The train is moving, But those who are sitting in the same train, you are in the state of rest. But those who are observing from the outside, you are in the state of motion. Is it clear? So this state of motion or state of rest of an object can be described by considering these two parameters. First one is the time parameter and the second one is the reference object. So I think the idea is clear. Next we are moving into different types of motion. Actually, the motion of an object is complex. That means it can be moved in any direction. An object is moving from point A to point B in a straight line. We can call it as a linear motion. If the object is moving in a circular path, we can call it as a circular motion. An object is moving like a rotatory motion in a like rotating through an point, we can call it as a rotational motion. An object is moving in like this, that is like coming to one point, or it's vibrating, we can call it as a vibrational motion. So there are different types of motion exist in the world. The motion of a pendulum, clock pendulum, that is simple pendulum, that is also another type of a motion. Motion of your car wheel, that is also a example for a rotatory motion. The electrons revolving around the nucleus, that is it's moving in a circular path. And revolution of the earth, these all are different types of motion. So there are different types of motion exist in the world. Now we are going to discuss about a straight line motion or a linear motion. Actually, what you mean by a linear motion? An object is moving from point A to point B in a straight line. In a line, straight line, we are calling it as linear motion. So we are moving into the next concept, which is related to the linear motion, that is distance and displacement. For explaining the concept of distance and displacement, let us consider a person is traveling from point A to point B. He is taking a straight line path which is of 500 meters. So here the total path traveled is equal to 500 meters, isn't it? The second day he is taking another path for reaching point B from point A. That is like something like this, which is of 600 meters. So here this is the first case. In the second case, the total path traveled is equal to 600 meters. And I am asking you to calculate the shortest distance between these two, that is point A and point B. What is that? The third task is shortest distance between point A and point B, that is equal to 500 meters, isn't it? So here which one is distance and which one is displacement? Here the shortest distance between the 2 points, that is 500 meters, we are calling it as displacement. Is it clear? And the total path traveled, we are calling it as distance. The shortest distance between the 2 points, we are calling it as displacement, and the total path traveled by the person, we are calling it as distance. And in one case, the distance and displacement will be equal. That means, I'll give you one more example. A person is traveling from point X to point Y in a straight line. Here something like 100 meters. Okay, here the distance is equal to how much he traveled? 100 meters. And what is the displacement here? Displacement is also equal to 100 meters. What is displacement? The shortest distance between the 2 points is called as displacement. Here the shortest distance is 100 meter. Is it clear? So we already saw that what is actually meant by distance and displacement. How you can define this distance and displacement? Displacement, we can define it as the shortest distance between the 2 points. The shortest distance between the 2 points, we are calling it as displacement. See, even this is point A and this is point B. What is the shortest distance between these two is nothing but the straight line distance between this point, isn't it? So, in other words, you can say that the straight line distance between the 2 points also we can calling it as displacement. And what is this distance? Distance is nothing but the total path traveled by the object or the person, we are calling it as distance. Next we are coming into this unit of distance and displacement. The unit of distance and displacement is same because there we are calculating the length or the distance between the two objects. One is shortest distance, other one is total distance traveled. So the SI unit of distance and displacement is meter. Even when you describe a parameter in physics, it contains two parts. That one is the magnitude, other one is direction. We already saw that the magnitude of the distance and displacement is same when an object is moving in a straight line path. Example, a person is traveling from point A to point B in a straight line. Here the distance is equal to the straight line distance between them and the displacement also same as like the distance. So in the next video we are going to discuss about uniform motion and the change in velocity. Thank you. Come, let's start. Enjoy the beauty of physics. Please don't forget to subscribe my channel.